So welcome to the control room. So this is where the combiner box we were just looking at comes down through that tubing and it comes out here. So this is larger wire than was connecting the panels because we combined those two strings together in the panel, so then we needed bigger wire for the two. And that's going to land in the charge controller. Charge controller is basically the brains of a battery-based system. If it's just grid tie, often the inverter will hold the brains, but what happens is the inverter is post-batteries and the charge controller is pre-batteries, and so on a battery-based system you need the charge controller to tell when the batteries are full. You need it so that the batteries don't charge the panels at night. You need it for a number of different aspects of knowing how to keep the energy flowing, what levels to take. So you can see a few numbers on here, like how many amps are coming in, what the voltage is. Right now the voltage is at 31 volts, and that's reflecting the voltage of our battery system. And the reason it's at 31 today for our 24 volt system is we're equalizing. We're trying to give our batteries a supercharge today. And you can see 10.7 amps coming in there at here at noon in Baja. And yeah, so everything's looking good. Then these wires then come out of there, and then we can trace these along and have them come through the disconnect. So this is just, the disconnect that if I want to throw a switch kind of between the charge controller and the batteries, I can throw that switch, and that just cuts off any incoming power. And then that comes over here. This is my big disconnect box. So this has the main disconnect from the batteries to the inverter. So this big switch, the reason it's so much bigger is because look at the size of this cable coming from the batteries into the inverter compared to the size of the cable going from the solar panels into the battery. And what the size of the cable is about is that, like, we've only got a few amps ever flowing from the panels into the batteries, whereas like there's hundreds, thousands of amps going from the battery into an inverter. And so the other thing I wired in here is I did this little trimetric unit. This is a great diagnostic tool, especially if you're kind of like super into like maintaining and kind of geeking out like on kind of like, oh, what's my system at? It's going to be more accurate because of where the wires are landing than the charge controller. The charge controller gives you like kind of a rough estimate of your battery voltage and the amps and the volts coming in from the panel. This thing has a lot more brains just because of where you're landing all those wires. So basically this comes in here. Maybe I'll open this box up in a later take, but it lands on a DC bonding block, which is just a small piece of metal that takes lots of wires, and then from there I'm running to the batteries through these big honking 4-aught cable. So then that goes into the batteries. I put the batteries. You want to keep your batteries isolated from your solid state electronics. The batteries are going to off gas just for safety, for longevity of your solid state electronics. Like, keep the batteries in a different zone. So we have a little concrete box built on the north side of the house. Stays in the shade most of the year. We have an insulated lid, ventilation on the side, so it's like trying to keep the batteries cool. We'll go peek at the battery box too. And basically when it comes back through here, whenever I turn a load on in the house, then it's just saying, hey batteries, send me some power. It comes through here, lands on the bonding block, comes through this disconnect, so I can just cut here if I ever want like to make the house off the battery power. And then it's coming into here, and this is landing in the inverter, and the inverter is taking 12 volt power. And that's the reason why there's so many amps, is because that 12 volts is like, is maybe providing 1,000 watts. Like, it's maybe providing like, some appliances that you're using might be 1,000 watts. And so like 12 volts, like that's like, 80, 90 amps like coming through there. And then basically, coming out the other side, the inverter out are just these little dinky wires kind of coming down here, which is like once we inverted the DC to the AC, and now we're looking at 120 volts, all of a sudden the amps are cutting in a tenth. So it's like, you know, like it's just like these are coming down very small. Well, this isn't actually it. It's this wire, so it's not that small. This is the generator. So what this is like I can plug these wires into my generator to feed the inverter if my batteries aren't charged enough. And this one comes down here. So this is my disconnect for my solar coming there, and then you can follow this line all the way down into the house. So yeah. That's the control room, just kind of a basic intro to all the different component parts, and, you know, hope that feels good. Like, you know, again, we got the charge controller, we got the panels coming down through the combiner box into the charge controller, controlling the entire thing, running a wire, making sure you have good disconnects between your batteries and any solid state electronics. So you got a disconnect here, and then running out to the batteries, and then so that's the source, that's the panels going into the batteries, that's feeding my system, and then the batteries feeding through here into the inverter, and then feeding the house. That's how I'm, you know, creating, generating, using all my power. So that's good. We'll peek right outside this door.